My name is Vishanka, and this is my humanoid robotic head.
This is my humanoid robotic face system. It uses more than 20 servos that controls the eyes, eyebrow mechanism, cheeks, and the mouth mechanism. Everything about the face is designed so it can communicate through expressions, not just sound. Every part of the head was 3D printed at my school, Gymnasium Hakshada, which has been supporting me and even funding the project as it expanded. The neck you see here is still in its early versions. Right now, it works mostly as a stand, but I've already started planning a future upgrade using linear actuators to give it the smooth, natural movement. For the printing, I used PLA. The system runs on two Raspberry Pi Picos, and one handles the eyes and the eyebrow mechanism, and the other the mouth and the cheek mechanisms. And all these were driven by PC9685 servo drivers. One thing people don't usually realize is how much precision hardware a project like this actually needs, and how expensive it all gets. All of the shoulder bolts I used are made of brass, and I had to solder nearly 70 of them directly into the 3D printed parts. Each one had to be heated just enough to melt right into the plastic without deforming the surrounding structure. It took hours of slow, careful work, and honestly it felt like I spent weeks just soldering the hardware by hand. The screws were another challenge. I used dozens of M2, M3, and M4 stainless steel screws, and they end up being one of the most expensive parts of the whole build. Some of them cost around €2 each. The mouth mechanism especially pushed everything to its limits. I didn't want a simple hinge. I wanted something expressive, so I designed realistic gums and teeth in Blender, then spent weeks engineering the servo system that drives the mouth. I tested every individual servo, not once but hundreds of times, until the movement felt smooth and human-like. The code for the mouth is around 400 lines, all dedicated to getting the angles, timing, and motion exactly right. It took so many iterations, but in the end, every tiny detail matters, because this is a part of the humanoid robotic head that people connect to first. The eyes was something totally new for me, a challenge I set for myself because I wanted to push my limits. Instead of using screws or metal hardware, I designed the entire eye mechanism as a pure snap-fit system. That meant zero screws. Every part had to lock perfectly into the next, almost like a 3D puzzle. It sounds simple, but getting a snap-fit design to work at this scale and precision was insanely difficult. I spent so many hours in the school's 3D printing lab adjusting tolerances, reprinting parts, and testing fit after fit. Sometimes I print the same tiny component 6 to 5 times in one day just to get that perfect click. The eye assembly uses 6 servos, and once everything was aligned, the movement became incredibly lifelike. It can track up, down, left, right, and even add those small micro adjustments, which make the face look alive. Honestly, the eyes end up being perfect cherry on top. For the AI system, I integrated ChatGPT 4.0 using a custom API key. I wrote the full pipeline for speech to text, then text-to-speech, and response handling. The STT and TTS modules run fully offline, so the system operates without cloud dependency and
Hey
maintains
there,
low latency
how's it
interactions.
going? Smiling face with smiling eyes.
Can you tell me the boiling point of water?
Sure. Water boils at 100 degrees Celsius or 212 degrees Fahrenheit. Hot stuff.
Should I get physical therapy if I have back pain?
Absolutely. Physical therapy can work wonders for back pain. Better movement, less pain.
Thank you. Goodbye.
Goodbye, human. Powering down.